Hello guys, today I am going to explain the data pre-processing techniques. So those who are going to watch for the first time, please like, share and subscribe my channel. So this is the data pre-processing part 2 guys, and this is one of the important question which was directly asked for 15 marks in the latest question paper. So that is the reason I am explaining the part 2 also. So try to listen it carefully till and watch till the end of the video. So we'll see, or in the part 1 I have explained what is meant by noisy data, how to clean the noisy data, what are the smoothing techniques are there, everything I have explained. If you want means I will share the link in the description box. You can please check it, and you can listen that video also. Before listening this video you have to listen that video first and see what is meant by the data integration. See, data integration means it is nothing but combining the data or retrieving the data from the multiple sources, and we are going to store it at one single place. That is called as the data integration. But suppose if I am going to take any data from the multiple sources, can I get the same data? Can I get the same formats? Can I get the same attributes names? Can I get the same data types? Definitely no. We will be having multiple types, multiple formats, and multiple columns will be there, which will not be matched with the previous data. So that's why we are going to get one problem that is called as the entity identification problem. This is my entity identification problem I am going to get whenever I am trying to match from the multiple sources. See here, if I want to identify the real world entities from the multiple data sources means, see here Bill Clinton is there and William Clinton is there. So we know that both are same. But the thing is, they will represent in the different manner. So this is called as entity identification problem. And detecting and resolving the data value conflicts here. Means for the same real world entity, attribute values are different from the different sources are different here. So for the same real world entity, the attributes values will be different. Suppose if I take the customer name like John Henry. So in how many types I can write that particular name? I can write like John Henry, or I can write it like J Henry. I can write it like Henry John. I can write it like H John. So like that, different values I may represent for the same customer name. So these type of problems or conflicts may arise while merging the data from the multiple sources. And what are the possible reasons? It can be, what are the possible reasons means we can represent in the different representations, different scales of values I can use it, different metrics I can use it. And because of all these reasons only, I am going to get the conflicts in the data. So this is the main problem which is called as the entity identification problem we are going to get in the data integration. Next one is the handling the redundancy in the data integration. Now, if any redundant data is there means how to handle such type of data here. So first one is the object identification and second one is the derivable data. So what is that object identification means? The same attribute or the object may have the different names in the different databases. So first thing is I have to find out that particular attribute and see that all the data values in that column, it has to be normalized in the one different format. And next one is the derivable data. Derivable data means one attribute may be derived attribute in the another table. Suppose the annual revenue. From one attribute I can derive with the another attribute here. This is called as the derivable data. So one example is the annual revenue income. How I may get my annual revenue income? So if I want to get this annual revenue income means first I need to get my Jan to December revenue income, that which I am going to get. So based upon the all the monthly information only I can get my annual revenue income. So that is called as the derivable data. If one attribute is going to depend on the another attribute to get the complete information, that is called as the derivable data here. So redundant attributes, how we can detect it means we can detect the redundant attributes with the help of the correlation analysis and the covariance analysis. See, what is this correlation analysis? This is one of the important question again, correlation analysis. See how the correlation analysis we can find out on the nominal data here. So we are having one good technique is that is called as the chi-square test. So chi-square test is how we can perform this chi-square test is equal to sigma of observed minus expected whole square by the expected. This is the empirical equation. We are going to use it for finding the chi-square test. What is meant by correlation? First of all means I have to find out whether one attribute is completely dependent on the another attribute or not. Any correlation is there between the two attributes. So I want to find out, suppose let's take the two attributes like a student, marks, reading. In what way all these three attributes are correlated to each other? If a student reads in a very good manner means he will get the good marks. So definitely correlation will be there in reading, in getting the marks for a student. So like that I have to find out whether any two attributes are related completely or not. Any correlation is there between the two attributes or not. So we can find out with the help of the mathematical equation here. And the cells that contribute most to the chi-square are those whose actual count is different from the expected count here. And the correlation here, they have given one example like the number of hospitals and the number of car thefts in a city are correlated or not. Is it true? So it will depends upon the number of hospitals and the number of car thefts in a city. Definitely no. And again, these are linked by a third variable which is called as the population. So one more variable or one more attribute they have taken, that is called as the population. So I have to find out whether these three variables are correlated or not. Next one is a simple chi-square calculation. One example they have given. See here, I am having the playing the chess is there and not playing the chess is there, and some of the columns and some of the rows is there. But here I am having the three different types of variables are there. One is science fiction movies, and one is who doesn't like the science fiction movies, and one is the column information. So here, this is my chi-square calculation. But here, if you see those who like the science fiction movies are the 250 people, and here 50 people are there, and total if you take the summation here 300 are there. But whatever the parenthesis values are there, these are called as the expected count. That means this is the expected count of how many people are interested in playing the chess and how many people are not interested in the science fiction movies and all. So these are called as the expected counts here, and this is the actual value here. Then how the calculation can be performed for the chi-square is equal to means 250 minus 90. That means the difference between the actual and the observed values will gives you the chi-square test. So here 250 minus 90 and then plus, what is the denominator here? The denominator I am going to take it like 90 only, plus, and again this value 50 minus 210 whole square plus 200 minus 360 whole square by 360, and again 1000 minus 840 whole square by 840. So which will gives you this particular equation, that is called as the 507.93. So it will shows like the science fiction and playing the chess are correlated to each other in a group. So that means playing the chess and as well as those who likes the science fiction movies will always be correlated within the group. And here, how the correlation analysis can be done on the numerical data. So, if any numerical data, this is called as the nominal data, like those who will like the science fiction movies or non-science fiction movies. These are called as the nominal data. But here, how the correlation analysis can be done on the numerical data. So on the numerical data, correlation coefficient I can find out here. What is that correlation coefficient? Means nothing but Pearson's product moment coefficient here. So that is called as R of A comma B here. So here sigma I is equal to 1 to n ai minus a bar into bi minus b bar by n minus 1 into sigma a into sigma b. So where sigma a and sigma b, these two are the standard deviation A and standard deviation B here, and a bar and b bar are the respective means of A and B here. And that is sigma I is equal to 1 to n ai bi minus n into a bar b bar by n minus 1 into sigma a into sigma b. So for the numerical data, I can find out whether my R of A comma B is greater than 0 or not. If that is greater than 0, A and B are positively correlated. But if the values are is equal to 0 means they are independent. And if the values are less than 0 means they are negatively correlated to each other. So negatively correlated to each other here. This is the way how to compute the numerical data, how to compute the correlation analysis of numerical data here, So let's go into the next slide. like how to perform the normalization techniques on the given data. So basically, we are having the three different types of techniques are there in the normalization. What are those three different types of techniques means? So that is the min-max normalization, z-score normalization, and normalization by decimal scaling. These questions they may ask you in the 2 marks questions also sometimes. So that's why you prepare well. These are normalization techniques. Simply they will ask you what is meant by z-score normalization, what is meant by min-max normalization, what is meant by normalization by the decimal scale. So simply they will ask these questions in the 2 marks. So prepare these normalization techniques also. So now let's see what is meant by the min-max normalization. So min-max normalization means it will performs the linear transformations on the original data. That means suppose that min A and max A are the minimum and the maximum values of an attribute. Okay, now I am having the minimum and the maximum values of one attribute. Suppose if I take one example, we will see here. A min-max normalization maps the value V of A to value V bar in the range. That is, I am having the new min A values are there and new max A values are there. By computing, how I am going to compute the values here? V bar is equal to V minus min A by max A minus min A into new max A minus new min A plus new min A. So this is the equation for calculating the min-max normalization here. And see here, they have given one example like suppose if I am having the minimum and the maximum values are there for the income. What is my minimum value here? $12,000. What is my maximum values here? $98,000 are there. I would like to map the income within the range of 0 to 1. Within the range of 0 to 1 only, I would like to map my income value here. So now I will go for the min-max normalization. What is that min-max normalization? What is the value I am having? I want to normalize this particular value. That is the 73,600 for the income which is transformed into. So I have used the previous equation here. That is the V minus min A. What is meant by V minus min A? What is the V here? Value. So what is the value here? V is equal to 73,600 minus A. What is meant by min A here? Min A is the 12,000 by. And again, what is the max A minus min A? What is the maximum value here? 98,000 minus 12,000 into. And what is the new min A value? So whatever the range of values that which I have taken, these are my new min A value and new max A values here. So here 1 minus 0, I am going to take it plus 0. So here this is the value which I got out. That is, this is the normalized value for my given value. That is the $73,600. Next one is the z-score normalization. Z-score normalization means this will normalizes the value with the help of the mean and the standard deviation. If you are having the mean and the standard deviation values means then I can go for the z-score normalization technique. See what is this V bar? V bar is equal to V minus A bar by sigma A. So where A bar is the mean value and the sigma A is the standard deviation value here. This is the, if these two values are there means easily you can go for the z-score normalization technique. And next, we will see the example of the z-score normalization. Suppose here, if you see, I am having the mean value is there and I am having the standard deviation values are there. Like 54,000 is my mean value and 16,000 is my deviation values. So with the z-score normalization, a value of 73,600 for the income is transformed to 73,600 minus 54,000 by 16,000. Why? Because I am having the equation like V minus A bar by sigma A. What is my V value here? 73,600 minus what is my, here what is the A bar values? That is the 54,000 and what is the sigma A here? 16,000. So if I calculate, I am going to get this value here. That is the z-score normalization. And next one is the normalization by decimal scaling. So how the normalization can be done by the decimal scaling means here. Decimal scaling will normalize this by improving the, that means if I want to convert into some decimal point of values for a given attribute means simply I can do the normalization with the help of this equation. That is the V bar is equal to V by 10 power j. V by 10 power j, where j is the smallest integer such that maximum of V bar always it should be less than 1 here. So we will see with one example about the decimal scaling of the normalization here. Suppose if I am having the range of values like minus 986 to 917 here, the maximum absolute value of A is the 986 And to normalize by decimal scaling, we therefore divide each and every value by the 1000 here, so that minus 986 will be normalizes to the minus 0.986 and the 917, which will normalizes to the 0.917. So based upon the given values only, I will take the normalization of the values, whether to divide it with 100 or 1000 or 10,000, like that. So that is about the data normalization techniques and data integration techniques here. So that's all for today, guys. I think you like this video, guys. Please share and subscribe my channel.